let us look at this question, which is 2021 GCE on organic chemistry. So we are saying that the structure displayed below is a polymer that was formed from monomer Y. So now, before we go to the question, let us understand what a polymer is. So you'd find that the polymer is made up of a monomer. So monomer, they make up a polymer. So when we say a polymer, we are saying that this is a micromolecule which is a giant. So this one, it is a giant molecule formed by joining similar units just. So units which are formed, we can give an example of maybe polyethylene. So polyethylene, it is a polymer. So now polyethylene, we can say, so we have ethene, we know it has, so we have that, and then what else? So another one. So meaning that it is surrounded by hydrogen atoms. So here we have H there, H there, H there, and then there, also there, and then, so meaning that this is a polyethylene. So polyethylene. So now this one, it is a polymer. Now it is made up of different monomers. So we can give an example of number one, which is ethene. So which is ethene here. So now ethene, in this case, we have how many ethenes do we have? So we have two. If at all we cut it here, so we're going to have two. So this bond here will be shift, or it will shift to have double bonds, and then here also will cut, and then it will shift, and then we're going to have double bonds. So in this case, what do we mean? We mean that, so we have double bond there, and then we have, so it means that this is an example of, so another, so there, and then H, and then, so we have, so there. So meaning that, what are we going to have? We're going to have a polymer there. So a polymer, it is a giant which is made up of different or monomers. So in this case, we have to identify what this is. So we have to identify what we've been given here. So now, before we go any further, it is very important that we understand and we know what we are talking about here. So now, when you look at it very closely, you'd find that the first of all that you have to know is that this is a polymer. Now, why have we identified to say this is a polymer? Because we have these covalent bonds, these, meaning that they are not closed. So let me give an example of something which has been closed. So like we have ethene there, so ethene, and then we have, and then, so here we have H there, and then, so meaning that this one, it is closed because we don't have. So carbon atom is surrounded by 4 covalent bonds. So here, when you count, you're going to have 1, 2, 3, 4. So meaning that it is closed. Now when you look at here, it is not closed, meaning there is that opportunity of an extension of other monomers. So other monomers can be extended because the bonds are open here. And then when it comes to identify, so we can identify this. Now name the polymer. Name the polymer. So the polymer that we have, first of all, because it is a polymer, so you have to write to say this polymer, it is first of all, because it is a polymer, it is made up of different monomers. So let us identify these monomers. So now when you look at these monomers very closely, you'd find that they are, so when we cut here, so we're going to have this one, and then we're going to have also this one here. Now what is this? So now this is what we call butane. So this is a butane. So a butane, we can write it here. So a butane, so that is a butane. So now this butane, we are saying that it is made up of 4 carbon atoms. So it is made up of 4 carbon atoms. What are those 4 carbon atoms when you look? So we have the first one, it is there, and then the second one, the third one, and then we have the fourth one there. So that is, now because we've identified to say this is butane. Now when we say a polymer, so meaning that we're going to add polymer or poly and then butane there. So in this case it is so we have polybutane. And then what else? So name the monomer. So the monomer, we've identified the monomer. So the monomer, it is butane. Okay, so we can construct the displayed structure of a monomer or monomer Y. So monomer Y, this is what we want to know what monomer Y is. So monomer Y. So monomer Y, we've said monomer Y is butane. Now the structural formula. So we can say it is, remember, it has how many carbon atoms? So 4 carbon atoms. So we'll start writing by saying, so we have, okay, so we have 2. And then what else? So we can write there, so we have 1, and then there also, and then so the structure H3, and then here what are we going to have? We're going to have H there, and then a 3 there. So now when you compare this one that we've drawn here with the structure which has been given, which is a polymer, so have we seen? So it means that we just had to cut here and then we pick one. So it means that that is a monomer that we've listed there. So monomer Y was reacted with steam. So monomer Y was reacted with steam under suitable conditions, and an organic compound Z was produced. So organic Z was what? Was produced. And then the question is, to which homologous series does compound Z belong to? So if we have steam here, so if we have steam, so steam is what? Is water, or we can say that is in a gas. So that is gas, because this is water. So now you'd find that once this Z was produced, so monomer Y, this, which is we can write to say a butane. So butane reacted with what? With H2O. So now what are we going to have? What are we going to have? So you'd find that because we have hydrogen here and we have oxygen here, so meaning we are going to have hydroxide. So hydroxide will be produced. Now when you remember very well, you'd find that this one, it will help us to identify the family where the homologous series belong to. So in this case, that is an alcohol. So alcohol. So meaning that that is the answer there. So meaning that the homologous series does compound Z belong to, that is alcohol. Write the general formula for the homologous series stated in. So we write the general formula. So you find that the general formula is very simple. So make sure you commit to these formulas so that it is very easy for you to understand. So that is the formula there. We are still dealing with 2021 GCE, and then so hydrocarbon V, which contains only 3 carbon atoms, was bubbled through a bromine solution, and there was a rapid decolorization of solution. So identify hydrocarbon V. So we have to identify hydrocarbon V. So now here the statement obviously will help us to give us an answer. So hydrocarbon V contains only 3 hydrogen or 3 carbon atoms was bubbled. So meaning that what is it that has 3? So what is it that has 3 carbons? Was bubbled through bromine solution, and there was a rapid decolorization of solution. So identify hydrocarbon, which is V. So we have to identify this hydrocarbon. So V. Okay, so meaning that it has 3. Now, when you look at, let us look at which one has 3. So you'd find that ethene has how many carbon? So it has 2 carbon. And then which follows is propane. So propane has how many? So it has 3 carbon and 6 hydrogen. So here, what do we have? So meaning that is direct to say the answer is what? The answer is propane. So because it has 3, we can also identify and know, because it has how many 3. So we will draw the structure here. So the answer there, it is propane. So propane. And then draw the structure of hydrocarbon V. So hydrocarbon V, we're going to draw it here. So hydrocarbon V, the structure, remember it has how many carbon atoms? 3. So meaning we're going to say 1, 2, and then we have 3. Now because it has 3, how many hydrogen atoms? 6. So we have hydrogen atoms 6 there. So here we're going to have 1, 2, 3, and then what else? So here 1, 2, 3, and then what else? Let us put another one here, 3, 4, and then also 4, 5. Where else can we put 5? So how many? 5, and then the other one, where can we put it? So we can put it here. So we have 6. And then remember, because here we don't have, here or on the first C we don't have, the first carbon we don't have. So meaning that, remember, carbon is surrounded by 4 covalent what? Bonds. Now in this situation we don't have. So meaning we're going to say here we're going to have 2, such that the first carbon is surrounded by 4 covalent bonds, and then even the third one is surrounded by 4. So this is the structure there. And then to which homologous series does hydrocarbon V belong to? Now remember we have that is the sulfurics there. So will help us to identify the family that it belongs to. So meaning that is an alkane. And then write the general formula of homologous series where hydrocarbon V belong to. So it is very simple. That is CnH2n. So that is the formula. Explain the dangers of burning hydrocarbon V in limited oxygen. So you'd find that explain the burning of hydrocarbon V in limited. Limited, when we say limited, meaning that it is not complete. So it is incomplete. So we can say when you burn it, you'd find that carbon monoxide will be produced, which can cause people to suffocate. So when carbon monoxide is produced, carbon monoxide will consume, it will absorb oxygen. So we can give an example. If you burn, or if you put charcoal on a brazier, and then in an event that you start cooking, but carbon monoxide will be produced when the charcoal is not fully burnt. So carbon monoxide will be produced. Now in an event that you've closed the doors, the windows, and there is no ventilation, meaning you can die because of suffocation. Carbon monoxide will consume every oxygen which is inside. So we can say, because it is limited, so limited it is not complete. So we can say incomplete. So incomplete combustion will take place, producing carbon monoxide which can cause suffocation. Okay, so we can move to the other one. Write the balanced chemical equation for the reaction in B and then one above. So B1 above, this one, carbon V is limited in what? In oxygen. We have to write this one. So we would say, because we are looking at propane, so propane, that is, we have 3, and then H, we have how many? 6. So plus oxygen, and then what are we going to have? So meaning that carbon monoxide will be produced plus H2O. So in this case we have to balance. So here we have how many? So we have 3. Here we have only 1. So we can put a 3 here, so that we have carbon 3, and then we have carbon 3 here. And then what else? Oxygen. Or let us move to hydrogen. Hydrogen, how many do we have? Hydrogen 6 here, and then hydrogen, how many do we have? We have only 2. So we can put a 3, such that when we multiply 3 by 2, we're going to have 6. What else? Let us move to oxygen. Oxygen, we have 2 here. How many oxygens do we have here? So we have 3, and then again we have 3. So 3 plus 3, that is 6. Even here, here we have, so meaning we can put a 3 also there, so that when we multiply 3 times 2, we're going to have a 6. So under suitable conditions, the hydrocarbon V was polymerized and polymer W was produced. Display the structure of a polymer W. So polymer, we are saying that a polymer, it is a giant, it is made up of monomers. So we can, where can we write it? Let us find the space here. So that is where we're going to write. Okay, so we want to write the what? For W. So under suitable conditions, hydrocarbon V was polymerized and polymer W was produced. So in this case, what are we going to have? So we're going to pick the things that we have. Let us look at, do we have the structure? Okay, we have the structure here. So we have the structure there. So meaning that it was polymerized. So how many times? So we're going to say, do we have space here? Okay, so we would say number 1, so we would say number 1, we would say how many, let us identify how many carbons do we have. So we have 8, so we can write, so 1, and then we have 2, 3, 4, 5, 6, 7, and then we have 8 there. Then we're going to have another one, so it's surrounded by 4, so we'd say hydrogen there, and then we have hydrogen there. And then what else? So we can only get this one. So this one will be what? Not this one. So we're going to have only 3 here. So it will be C H what? H3. So we're going to put it here. So that is CH3, and then here we're going to put H there, and then what else? So we're going to have another one, H, and then H there, another one. What are we going to have? So we're going to have CH3, and then here, okay, H there, and then H there. What are we going to have? H there, and then here, so that is H3, and then here, what are we going to have? H there, and then here we have H there, and then we have CH3. Now here it is not closed, meaning that there is an opportunity for another extension here. So meaning this is the answer for polymer W which was produced. So we have another question which is 2019 internal. So now here they've said, so we have nylon and terylene polymer. So what is meant by the term polymer? So the term polymer, you'd find that polymer, you cannot have a polymer if you don't have a monomer. So monomers, they make polymers. So monomers, they make polymers. So monomers, these are small. And then when we say a polymer it is a giant. So we are saying that a polymer is a giant. So a polymer is a giant. So it is a giant molecule formed by combination of small molecules. So small molecules, they make, which we call monomers, they make a polymer. So apart from being polymer, give one similarity between the two. So the similarity between the two, which is the similarity between the two, we can say both are synthetic polymers. So both are synthetic polymers. So why have we said that both are synthetic polymer? Because these two, so these two, you can get them, or they are derived from petroleum oil. So these are derived from petroleum oil. There are other examples that we can give. For example, an example that we can give is Teflon. So Teflon, it is another example, and then epox, that is another example that we can give. Not only that, even polyester. So polyester, it is another example that we can give on synthetic polymers, apart from the two that we've been given here. So which of the two polymer is a polyester? This one I've stated here. So which is a polyester? Now between the two, which one is a polyester? So we have to understand what a polyester is. Now a polyester, we have to know what it means and what a polyester is. So a polyester is that polymer that contains ester functional group in every repeated unit of their main chain. So that is it. So that is it. Now when you look at the two, which one? So there is a repeated. So now what is this repeated formula? So we can say this is a repeated formula that we're going to put here. So we have R there, and then we have so this one is now repeated. So this one is repeated. So between the two, which one can we have? So let us start with the nylon. So nylon, does it have what it takes for it to be called this? What does it take for it to be called like we've called to say it is a synthetic? So which one? So the answer, obviously, it is not that one, but it is a telen. So that is an example that we can give which of the two is. So let us move. Hence, draw the structure of the polymer shown 2 repeating units in cycle any ester link on the chain. So we have to give and we have to draw here. So how do we draw? So we can say number 1 we have so okay, so this is a link. That is also, and then so we have also so we have O there, and then we have C, then double bond there, and then what are we going to have there? Yes, so again we write C, then here it is C double bond O, and then we have O there, and then we have also another O there. So it can be going just like that. So it can be going just like that. So now here we have okay, we can differentiate the two. So let us differentiate the two so that we know and identify. So now when you look at here, this one, so this one and which one? So we have also this one here, and then we have also this one there. So now when you look at this, these are what we are calling ester link. So these are links which are connecting and to make the chain. We are still on 2019. So 2019, and then now butane, which is we have butane here, is a compound belonging to the alkane series. State the general formula for alkane. So we have to state the general formula. So the general formula is simple. We've been stating this general formula. So we have H2N, that is, or this is the general formula. Okay, so display or draw the displayed formula of the second member of the series. So the second member of the series, how do we know the second member of the series? The second member, so we can write the second member to say we can draw which is the second member. Where can we draw? We find the space. Okay, where can we find? Okay, so now before we go to the second member, so what is the first member? So the first member is, the first one is which is ethene. So ethene, this is the first member. So the ethene is 2, and then we have H4. So meaning we have double bond there, and then we have C. So 1, 2, and then we have 3, and then we have 4. Now the second one, which is propane. So propane is the second one. So propane we have C3H, and then 6. So we have H6. Now how do we draw? So we can say we have 1, and then we have 2, and then we have 3 there. So meaning we should have a second, because we are going to have a double bond somewhere. So we would say we have 6. So here we would say 1, 2, and then 3 there. So 3, 4, and then where else? 4, 5, and then we have 6. So here we're going to put a double bond. Remember, it is surrounded by, carbon is surrounded by 4 covalent bonds. So meaning that this is the second. So draw the displayed formula of the second member. So the second member is propane. So propane. Now butane is cracked by cracking petroleum oil. Name the other method by which it may be prepared. So the other method in which it can be prepared apart from cracking. The other method that it can be prepared. So the other method is dehydration. So dehydration. So dehydration, we are saying that dehydration, that is where you remove what? Water. So that is the method. So butane can be polymerized. So name the type of polymerization it undergoes. So this butane can be polymerized. So what is this? Name the polymer. So because here we have 1. So because here butane we have 1, and then meaning we can add. So add, by adding, meaning that is additional. So we can say additional polymerization. So additional polymerization. Okay, draw, give the name of the polymer formed from butane. Show at least 3 repeated units. So we have to show 3 repeated units. So when we say 3 repeated units, meaning that butane, so butane plus butane plus butane. What are we going to have? So we're going to have polybutane. So that is what we're going to have, polybutane. So meaning we have how many? Repeated 3 times. So if it is repeated 3 times, meaning we are going to have this one also. We have the first one. So here the first question, we have to read it very carefully. So draw and give the name of the polymer formed from. So we have 1. Show at least 3 repeated units. So apart from the first one, then also 3 repeated what? Units. So where can we? Okay, so we're going to draw it here. So we would say the first one is, we have butane, which is the first one. So we'll write, so H, and then there H. Okay, so we have C, another one there, another one. So we have 4, and then here H. So even here we have H there, and then here we have H, and then where else? So where else? Here we have H, there. Then what do we have? Then we have H there. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. So we have 8. So for to make it easy, we are going to say, so we multiply it by what? By 4. And then what are we going to have? So So in this case, we are going to have polybutane. So which is how many? So we have 1, 2, 3, 4, 5, 6. So because it is a repeated, so we would say here we have, then there also, here we're going to have. Now this, for us to have, which will help us, meaning we should break it. So we should break it to say, if at all we have, let us assume we have that C and that C, so, and then we have one there, one there, and then we have one there, also we have one there. And then if we have here, which is, we're going to, let us find another one where we're going to have, sorry, we put it where we have to find, so that we can have another one. So if at all we're going to have another one which is like that. So now, because we have this one already here, so we have hydrogen already here, so here what are we going to have? We're going to subtract this one, so we would say C 2 and then H what? 5. Now this H5 plus this, then we're going to have 6 there. So even here we're going to say H, and then there also, then we have H there, and then what else we have there, and then here we have H, and then we have H. So here, because it is a polymer, meaning that it is not closed, it is not closed here, so it is not closed at the end here, again it is not closed at the end there, because there can be an extension. So now they are saying it was repeated 3 times, so we have the first one, and then we have also the second one, and then we have also the third one there. So that is our answer. Okay, so let us move to E. So E, butane react with steam, so that is H2O, in the presence of catalyst to form a colorless compound. Name the compound formed. So a compound, so remember when alkene, so we have alkanes, when they react with H2O, alcohol is produced. So alcohol is what is produced. So in this case, what type of alcohol was produced if butane reacted with what? With water. So we're going to say that is butano. So that is butano, which was what? Which was produced. So write a balanced chemical equation for the reaction between ethanoic acid and the compound named E1 above, including state symbols. So we have to include the state symbols now. So we have to include the what? The state symbols. So a balanced compound, so this compound in question E, so when it reacts with what? Butano reacts with ethanoic acid. So butano reacts with ethanoic what? An acid. So we have an acid, so we would say alcohol plus acid. So what are we going to have? So what are we going to have? Okay, so we're going to have an ester will be produced. An ester will be produced there. And then what else that will be produced apart from that? So apart from that, what else will be produced? So also water will be what? Will be produced. So apart from that, apart from an ester being produced, but also water will be what? Will be produced. So we can create that space. So an ester here, ester will be produced plus what? Plus water. Then let us create some space. Okay, we create some space. Okay, so always you should remember that alcohol, when it reacts with an acid, always an ester is what is produced. And then not only that, you'll find that any member of the alkane family, when it reacts with water, then alcohol will be what will be produced. Now in this case, the question here we are saying that an alcohol, so alcohol plus we have the ethanoic acid here, so which is an acid, and then so an ester will be what will be produced plus H2O, which is what which is water. Now we can write the chemical formula. So we would say the first one, which is the compound, which is butano. So we would say okay, H, and then we have hydrocarbon there, hydroxide. So the state of this is what is liquid, and then plus, which is an acid there, an acid. So an acid is aqueous, and then what else that will be produced? An ester. So an ester will be produced. And then plus what? Water. Now here it is liquid, and then here it is, do we have the state there? So meaning that this is the answer which was needed at the answer or the question which was given there.